In this section, we're going to talk about functional and non-functional tests and kind of the differences between the two and some of the examples of the testing that's being done in each of those sections. So let's get started. Remember in the previous section that I talked about that functional testing is testing against the expectations of the requirements, most likely requirements that you've set there. Whereas non-functional testing is testing for discovery of odd or weird or undesirable behaviors. For our course here, the primary focus that we're going to work on is functional testing, and specifically unit testing within functional testing. And I'll explain a little bit more about what that means. But it is important to understand what the differences are between functional and non-functional testing. So what exactly is functional testing? Well, functional testing has it's requirements based. So you're trying to make sure and verify that the thing that you designed, the thing that you created, meets the expectations that you have for it. There are four main types of functional testing that we have, and they kind of increase in scope as we go through there. So unit testing is the smallest component of testing. So you're testing small little pieces of software, things like functions and methods and creating a class or properties or those types of things. The developers who usually create unit tests typically are also the creators of the software. So if you've created the software, you usually typically create the unit tests as well. Unit testing is also great for debugging your code as well. And so that's it's useful for not only verifying that things are working, but if you're running into problems, you can use testing to try to figure out where exactly are you having the problems. Next up, we have integration testing. And with integration testing, you're testing the interactions of different units of the software. So for example, let's say you've got the Pokemon game, right? A Pokemon battle might be simulated, and you might do an integration test of that, where you're working on different classes and different functions and their interactions, and you're doing a lot of these basically scenario testing. Developers can create integration tests, but typically it's actually somebody independent of developers that start doing the integration type of testing and creating those test cases. System testing is where you take kind of a black box approach. You don't understand the inner workings of what the software does. You just know that there's requirements placed against it. And so you look at those requirements and you think, how would I test to make sure that that's it? Give this specific input, I have this specific output expected. Does that result in there? And what happens if I play around with the different inputs and work with that? So that's where system testing kind of comes in. That's definitely done by independent teams, usually dedicated test teams that do that. And oftentimes the system testing, when you start getting into that big of an area, if you're working with a true system where it's got multiple different types of components to it, you're going to be combining hardware and software as a part of the test. It's a broader thing. And then you have acceptance testing. And acceptance testing is like that final test. It's where you take all of these different types of testing, whether it's unit or integration or system, or even scenario type of testing, where you take a specific scenario and you pass it through. The acceptance testing is all of that collection, and it's done to verify that the tests are indeed, that the product indeed is working the way you have. And that verification can come from users doing like beta testing. It can come from an internal quality assurance type team. It can come from all sorts of different areas. I have here a Raspberry Pi, and I wanted to use this as kind of an example of the different types of testing that we have here. So on my Raspberry Pi, I've got a network interface, I've got some USB ports, and I've got an HDMI output. I've got my processor and a whole bunch of other different things in there. So a unit I would consider to be something like your network adapter. So before we ever take and assemble this Raspberry Pi, I would take this adapter and put it on a breadboard somewhere and test anything and everything that's kind of a part of that, right? And test all that and make sure that that actually works the way I would expect it to be. And then let's say we want to build up and start working on integration testing. So now let's say I've got my network cable, and I want to make sure that the browser, when it pops up, that I open a web page, that the network cable goes properly through that scenario of grabbing the data from the network card, gets processed on the CPU, and then properly outputted onto the HDMI. That's kind of like an integration testing. System testing would be, here's Raspberry Pi. Here is your network cable and your USBs. You have no clue what else is inside of there. I want you to serve up a web page and make sure that it works properly. Or I want you to do a scenario of these different types of things. So you don't know what's kind of going on inside of it. You're working onto those things. And then acceptance testing is where the collection of all that, and you say, yep, certified, this Raspberry Pi is working. So that's kind of the summary of what functional testing is. You have unit testing, integration testing, system testing, and then acceptance testing that's in there. Next up, we have non-functional testing types. So remember that non-functional testing is looking at ways to identify the system, to see, is it working in an odd manner? Does something happen to that? Again, it's not really super important as far as we're not going to create these types of tests, but it is important to understand and realize that they are out there, and it's a part of your testing suite that you may have to be working on as you progress as a software developer. These tests can include performance testing. So you basically stress test or do load testing or kind of endurance testing, or see what happens if you spike an input into your software, and see kind of what happens when that happens. Do you need to worry about rate limiting and those types of things as a part of your software? There's security testing, where you test the software or the system for known flaws and any security exploits. SQL injection is a very common security testing. You check to see if unsanitized inputs gets brought in, and does that cause changes to the database that you're interacting with. Usability testing. This testing is to check that is this system or software easy to use for the intended audience and customer. You can create the most wonderful and feature-rich set of software, but if the intended audience is not familiar with how to use the interface that you selected, it's not going to be worthwhile. Compatibility testing. This is testing for compatibility across different intended domains. Some examples are cross-compatibility with Windows, Mac, and Linux, or even like an Xbox and PlayStation, or what about Chrome, Edge, and even Internet Explorer. Sometimes you need to build a test to see, are they working across those different types of domains. So we just learned about functional testing and non-functional testing. That functional testing is the testing against requirements, and we have unit tests, integration tests, system tests, and acceptance testing. And non-functional testing, which is testing to see for any type of odd behaviors. And some of those examples could be performance or security or usability or compatibility testing. And that's kind of just a big summary of those different types of testing that we have out there.